This video is over section 12.4, addition and subtraction with rational expressions. I'm going to emphasize again the importance of restrictions and remembering that you cannot divide by 0. If you have a variable in your denominator, you're going to have restrictions. Always find your restrictions before you simplify. This particular section, as you go through the practice and the certify, it is not necessarily going to ask you for those restrictions, but I really do want to emphasize practicing that. So as I go through examples today, we're going to practice that. Remember that step 1 is to factor your denominators. Step 2, set each factor equal to 0 and solve. Step 3 is listing those restrictions. So the values that you find in step 2 are the restrictions or the values that your variable cannot be. The reason that we spent so much time in the previous lesson learning how to find your least common multiple was because we're going to use those skills in this section to add and subtract rational expressions. We're going to have to find a common denominator, which means we're going to have to find our least common multiple, which is also our lowest common denominator. Doesn't matter what type of fraction you have, if it's integers in your numerator and your denominator, or if you have polynomials in your numerator and denominator. Anytime you add and subtract fractions, you absolutely have to find a common denominator. So the very first step is going to be to factor your denominators in order to find that lowest common denominator. Second step, find your restrictions. Third step, you're going to multiply the numerator and denominator times whatever you're missing in the denominator. So each one of your rational expressions is going to have a denominator, and the pieces that are missing, because you're trying to find your lowest common denominator, are what you're going to end up multiplying both your numerator and denominator times. It's likely that each fraction is going to be missing a different piece. So each fraction is going to get multiplied by something different. If you remember back to the previous lesson when we added something along the lines of 1/3 plus 1/2 plus 7/8, when you found your common denominator, each fraction was multiplied times a different number to come up with that common denominator. Same thing is going to happen here. You do not, and you should not, distribute your denominator. You want to leave it in factored form, because when we get to the end, you may be able to reduce. So you're going to leave your common denominator as each of those factors. If you're lucky, some of your fractions are already going to have the common denominator and you won't need to multiply anything. Those are the best type. Well, actually, the best type is when you have a common denominator to begin with. But your fourth step is going to be to distribute the numerators and collect like terms. So you've rewritten each one of these fractions so that they have a common denominator, and you're going to have to simplify what each numerator is. Step 5, now you're going to add or subtract each of those numerators. So you're going to have that one common denominator, and you're going to take each of your numerators and you're going to add and subtract them. The next step, step 6, once you have your rational expression added or subtracted, you're going to collect the like terms. Step 7, you need to go ahead and try to factor that new numerator, because if you can, you're going to do step 8, which is reduce the fraction. That's why it's so important to leave that denominator in factored form. These steps are in Canvas posted, so that document is available for you. And we're going to jump into some examples. I'm not going to go into practice today because it's hard for me to get everything on one screen. So I'm just going to go with a whiteboard. And I'm going to write the problems out for you. These did come from the practice, but it's just going to be, I'll have more space and I think it'll be easier to keep things organized. These problems can get a little long. So the more organized you can be, the better off. example number 1. And really all we're doing is adding or subtracting. That's what your directions are going to be. So our first problem is 6x minus 6 all over 8x minus 2x minus 9 all over 8x. Remember that our first step is to find our lowest common denominator. This is a good problem because my denominators are the same. I already have my lowest common denominator. So step 1 is essentially done for me. Don't have to worry about that one. 8x, 8x. Step 2, find any restrictions. Again, your directions are not going to tell you this, but I want you to practice it because eventually it's going to ask you. So if you just get in that habit every time, it's going to be more productive for you in the end. To find your restrictions, if there's a variable in your denominator, you're going to have a restriction. So you simply set your variable, or excuse me, set your denominator equal to 0 and solve for your variable. So in this case, 8x equals 0. I'm going to divide both sides by 8. X cannot equal 0. That's my restriction. Step 3, I can skip because I already have a common denominator. If I didn't have a common denominator, in step 3, I would be multiplying my numerator and denominator times something so that my denominators, I did have my common denominator, but I don't have to worry about that. I don't have to distribute the numerators and collect like terms. Essentially, all I have to do now is do the math. So I'm going to subtract these two. So one big fraction bar here with 8x as my denominator. My first fraction has 6x minus 6, and I'm subtracting my second numerator there, which is 2x minus 9. Notice I put 2x minus 9 in a parentheses because I'm subtracting everything that's there. So I still have 6x minus 6, and I'm subtracting a 2x, and I'm subtracting a negative 9. So that gives me 6x minus 6 minus 2x plus 9 all over 8x. Now I'm going to collect like terms. I have 6x minus 2x, which gives me 4x. I have negative 6 plus 9, which gives me plus 3, all over 8x. You should look to see if you can factor your numerator. I can't. So I have my solution. It's 4x plus 3 over 8x. Example number 2. Seven x plus 5 over x squared minus 2x minus 15 plus 5 over x minus 5. I'm going to have to find my lowest common denominator first. In order to do that, I'm going to have to factor that first denominator, x squared minus 2x minus 15. I will tell you that typically when I have something like this problem where my first denominator is x squared minus 2x minus 15 and my second denominator is x minus 5, typically that denominator that is a single binomial is one of your factors. That's just a little bit of advice for you if you're struggling with factoring. But remember, we're good at that now, right? So negative 15, two factors of negative 15 that when I add them together give me negative 2. So I'm going to have x minus 5 and x plus 3. So my first fraction has the two factors of x minus 5 and x plus 3. My second fraction has a factor of x minus 5. So this is a situation where I don't have to do anything with that first fraction. It stays 7x plus 5 times x minus 5 times x plus 3. And I may have said that wrong. The first fraction is 7x plus 5 all over x minus 5 times x plus 3. It's the second fraction that I'm going to need to do some work with because it's missing something. So it has the x minus 5, but it doesn't have the x plus 3. So I'm going to have to take numerator and denominator times x plus 3. So I end up with 7x plus 5 over x minus 5 times x plus 3 plus 5 times x plus 3 over x minus 5 x plus 3. Let's do our restrictions really fast since we've got our common denominator figured out. So my first restriction is going to be x minus 5 equals 0. So I add 5 to both sides. X cannot equal 5. My second restriction is going to be x plus 3 equal to 0. Subtract 3 from both sides, x equals negative 3. So x cannot be 5 and it cannot be negative 3. Now we'll keep moving with this problem. I'm going to distribute over here in the right fraction, so I'm going to just leave 7x plus 5 over x minus 5 times x plus 3 as it is. And I'm going to rewrite the second fraction as 5x plus 15 over x minus 5 times x plus 3. Now I'm ready to write it as one big fraction where I have x minus 5 times x plus 3. And in my numerator, I have 7x plus 5 plus 5x plus 15. When I collect like terms in my numerator, 7x plus 5x is 12x. 5 plus 15 is 20. So I have 12x plus 20 over x minus 5 times x plus 3. I should go ahead and factor my numerator in case I can simplify. I can take out a greatest common factor of 4, which leaves me with 3x plus 5 over x minus 5 times x plus 3. I can't actually simplify anything there, but it's always good to practice. So when I get ready to type into Hawks, that's what I'm going to type in. 4 times 3x plus 5 all over x minus 5, x plus 3. Here is my third example. This time I have 7x plus 7 over x squared plus 3x minus 54 minus 3 over x plus 9. I'm going to come in here and I'm going to factor x squared plus 3x minus 54. I'm looking for two things that when I multiply them together give me negative 54, and when I add them together give me a positive 3. So that will be x plus 9 and x minus 6. That's my common denominator, x plus 9, x minus 6, because they both have an x plus 9 and the first fraction has x minus 6. So I'm going to have to take that second fraction, both numerator and denominator, times x minus 6. Rewriting this, I have 7x plus 7 over x plus 9 times x minus 6 minus 3 times x minus 6 over x plus 9 times x minus 6. We'll do the restrictions. My first restriction is x plus 9 equals 0. Subtract 9, x cannot equal negative 9. My second restriction is going to be x minus 6 equals 0. So I will add 6 to both sides. X cannot be equal to 6. And I'll finish working on my problem here. It's going to be keeping everything the same on that first fraction for now. 7x plus 7 over x plus 9 times x minus 6. I'm going to distribute first. So I'm going to subtract 3x plus 3x minus 18 over x plus 9 times x minus 6. I'm ready to start with my big fraction bar. My denominator is x plus 9 times x minus 6. And I have 7x plus 7 minus my entire numerator, which is 3x minus 18. So 7x plus 7 minus 3x plus 18 over x plus 9 times x minus 6. Collect like terms on the top. 7x minus 3x is 4x. 7 plus 18 is plus 25 over x plus 9 times x minus 6. And I can't factor that numerator at all. So that's my answer. 4x plus 25 over x plus 9, x minus 6. This is example number 5, actually 4. This time we have 3x squared over x squared minus 1 plus 3 over x plus 1. I'm going to factor this denominator on my first fraction. X squared minus 1 is a difference of squares, so that factors into x plus 1 times x minus 1. So my lowest common denominator is x plus 1 times x minus 1. So that second fraction is missing the x minus 1. So I will multiply top and bottom times x minus 1. This leaves me with 3x squared over x plus 1 times x minus 1 plus 3 times x minus 1 over x plus 1 times x minus 1. I'm going to distribute. I keep my 3x squared times x plus 1, 3x squared over x plus 1, x minus 1, plus 3x minus 3 over x plus 1, x minus 1. We did forget the restrictions, so we'll go back and do that really quick. First restriction, x plus 1 equals 0, which means x cannot be negative 1. Second restriction is x minus 1 equals 0, so x cannot be 1. Keep going with my problem. Ready to write one big fraction bar where my denominator is x plus 1 times x minus 1. I have 3x squared plus 3x minus 3. I can factor 3 out of my numerator. Leaves me with x squared plus x minus 1 over x plus 1 times x minus 1. And I don't think I can factor x squared plus x minus 1. So that's my solution. Ready for example number 5. X plus 8 over x plus 6 minus x minus 6 over x minus 8. Here, each of these fractions has a simple binomial factor in the bottom. So each one's missing what the other one has. This first fraction is missing the x plus 8, and this, excuse me, x minus 8. And this second fraction is missing the x plus 6. So I'm going to take x minus 8 times the numerator and denominator in my first fraction, and I'm going to take x plus 6 times the numerator and denominator in my second fraction. So my new fraction for the first one is going to be x plus 8 times x minus 8 over x plus 6 times x minus 8. I'm going to subtract. My second fraction is going to be x minus 6 times x plus 6 all over x plus 6 times x minus 8. Do my restrictions. X plus 6 can't be equal to 0, which means x can't be equal to negative 6. X minus 8 can't be equal to 0, which means x can't be equal to 8. Going back to the problem, we're going to distribute. The first fraction ends up giving me x squared minus 8x plus 8x minus 64 over x plus 6 times x minus 8. The second fraction, when I distribute, gives me x squared plus 6x minus 6x minus 36 over x plus 6 times x minus 8. Those two add to be 0, leaving me with x squared minus 64 in my numerator. On my first fraction, over x plus 6 times x minus 8. The 6 and the negative 6x there add to 0. So my second fraction is x squared minus 36 over x plus 6, x minus 8. I'm going to do one big fraction bar, x plus 6 times x minus 8. I have x squared minus 64. I'm going to do this without the parentheses. Hopefully you'll follow along. Subtracting a positive x squared, which means minus x squared, subtracting a negative 36 is going to be plus 36. And I'm running out of room, so we're going to move this step over here. When I get ready to combine like terms, x squared minus x squared adds to 0. So I have negative 64 plus 36, which actually ends up being negative 28 over x plus 6 times x minus 8. And I can't reduce that, so that is my solution. Example number 6. I have 4 over x plus 1 plus negative 7x plus 5 over x squared minus x minus 2. I need to factor that second denominator. 2 factors of negative 2 that when I add them together give me negative 1. So x minus 2, x plus 1. So my first fraction is missing the x minus 2. And I don't have to worry about the second one. It has both pieces. So my first fraction is going to be rewritten as 4 times x minus 2 over x plus 1 times x minus 2 plus negative 7x plus 5 over x plus 1 times x minus 2. My restrictions, x cannot be equal to negative 1 and 2. Hopefully you're getting pretty good at solving those. So that's what makes x plus 1 equal to 0 and what makes x minus 2 equal to 0. I'm going to distribute 4x minus 8 over x plus 1 times x minus 2 plus negative 7x plus 5 over x plus 1 times x minus 2. I am ready for the big fraction bar. 4x minus 8 minus 7x plus 5 all over x plus 1 times x minus 2. 4x minus 7x is negative 3x. Negative 8 plus 5 is negative 3 over x plus 1 times x minus 2. I can factor out a negative 3, which leaves me with x plus 1 over x plus 1 times x minus 2. This time, I actually can reduce. I have an x plus 1 in the numerator and denominator, so that leaves me with a negative 3 in the numerator and x minus 2 in the denominator. And it wouldn't have to be in parentheses. You could leave the parentheses off. So this is the first time we've gone through that process, and factoring the numerator actually allowed us to simplify something with our factored denominator. So it does happen. Example number 7. I think we'll do 2 more. We'll do 7 and then we'll do number 8. And then this one is 8 over x plus 4 minus 5x minus 8 over x squared plus 8x plus 16. So factoring that second denominator, I'm looking for 2 factors of 16 that when I add them together give me 8. So I have x plus 4, x plus 4. So my second fraction has 2 x plus 4s. My first fraction only has 1. And remember when we were doing prime factorization and you always counted the most number. So I can't just have the one x plus 4. I need both of them. So my first fraction is missing one of those x plus 4s. So I'm going to have to take top and bottom times that x plus 4. So my new fraction for the first one is 8 times x plus 4 over x plus 4 times x plus 4. And luckily, I can just subtract the second one, 5x minus 8 over x plus 4 times x plus 4. Restrictions, x cannot be equal to a negative 4. Distribute, and I have 8x plus 32 over x plus 4 times x plus 4 minus 5x minus 8 over x plus 4 times x plus 4. Rewriting it as one big fraction with my denominator being x plus 4 times x plus 4. I have 8x plus 32 minus 5x minus a negative 8 is plus 8. So 8x minus 5x is 3x, and 32 plus 8 is 40. So I have 3x plus 40 over x plus 4 times x plus 4. And there's no common greatest common factor for 3x plus 40, so that's my solution. 3x plus 40 over x plus 4 times x plus 4. Last example. I have 6 over 4 minus x plus 2 over x minus 4. Now, when you initially look at this problem, you're thinking, oh, those are really close. I have a 4 minus x, I have an x minus 4. The only problem is the signs are a little bit off. Well, we can take care of that because we can factor out a negative 1 and make this x plus 4 because it changes the signs. That -1 we don't leave in the denominator, we move that up with the numerator. So I rewrite my numerator as -6. My denominator is x plus 4. And then I have plus 2 over x minus 4. I did something wrong. Go back, go back. When I factor out a -1, both signs have to change. So I forgot to change the sign right here. This should be x minus 4. And this should be x minus 4. -6 plus 2 is -4 over x minus 4. And here your restrictions are x cannot be equal to 4. I'm actually going to do one more example because this one probably confused you a little bit. I apologize. We'll do another one similar to that one. Example number 9. -2x minus 1 over x minus 3 minus 7x plus 8 over 3 minus x. So again, the denominators look very similar. It's just in the first one, the x is positive, the 3 is negative. In the second one, the 3 is positive and the x is negative. You can change your signs by simply factoring out a -1, which leaves me with a -3 and a positive x. Now what I don't like to do is I don't like to leave the negative in the denominator. So when I rewrite this, -2x minus 1 over x minus 3 is going to stay that way. I keep the subtraction sign there. My denominator is x minus 3. But that -1 now is going to get multiplied times what's in my numerator. So instead of having it down there in the denominator, I'm going to move it to my numerator. It's just a math thing. We just like it better at the top. So I'm going to keep the -2x minus 1 over x minus 3. And I'm distributing my other numerator, which gives me -7x minus 8. So I have x minus 3 in the denominator. I have -2x minus 1. Subtracting a -7x is adding 7x. Subtracting a -8 is adding 8. -2x plus 7x is 5x. -1 plus 8 is plus 7 over x minus 3. All right, I haven't done a you try for a while, so I'm going to give you one to try. See how you do. Your problem, and I'll give you some time to do it, is -2x minus 1 over x minus 3 minus 7x plus 8 over x minus 3. So very similar to the last one. And I'm going to give you 3 minutes. You have about a minute left. All right, the timer went off. I think I was fairly nice to you all. I was pretty excited because I gave you one that already had a common denominator. That makes life much simpler. Restrictions first. X cannot equal 3. That wasn't a very good color choice. We can keep that denominator. I don't have to do any kind of manipulation. I have negative 2x minus 1 from my first fraction, minus 7x minus 8. Negative 2x minus 7x is negative 9x. Negative 1 minus 8 is negative 9 over x minus 3. I can factor out a negative 9. It leaves me with x plus 1 over x minus 3. I cannot simplify anything, so I can leave my answer just like that. Negative 9 times x plus 1 over x minus 3. Again, there are several steps, lots of places to make a mistake or miss a sign. You saw that I've done that already. You just have to be really careful. If you're in the practice and you don't get the little green bar and that positive affirmation, I always suggest that you go back and run through your work, make sure you didn't drop a sign. Really, the simplest thing you should look at first is making sure that what you have written on your paper is what you typed in. I find a lot of times that I will do a plus when I'm in a minus. So just be really careful. Make sure that the answer that you have on your paper is the answer that you're typing into the box. That's the first place to look. And then the next place is just go back and check your signs. If you still can't figure out what your problem was or where you made your mistake, you can go back. There's a tutor feature. You can go step by step. It can give you some hints about what might have gone wrong. If it's not a simple mistake, like a sign thing, you really need to do that trisimilar problem on that one. Make sure that you keep doing a problem that you're struggling with until you can do it really easily without looking at your notes. That's the key to knowing that you're going to be ready for your module exam. All right. Thank you, everyone. Hopefully you were successful in the You Try problem, and I'll see you in the next video.